Hi, so this video is about a problem I faced at work, a bug which I had to solve. So a little background about this problem is that we had this specific API whose job was to fetch a bunch of data from the database table and return it to the front end. Now it doesn't sound like a huge problem, but the thing is we were getting out of memory exceptions, and the reason was that we were fetching a large number of data in a single go without using any pagination, due to whatever design decisions and constraints we had at the time of implementation. Now I have to solve it, so just to show I have created a dummy project and small re-implementation or reproduction of this thing. So what we had is, let's go into this API, find all projected by. Now here you can see how we were doing. What we were doing is we had a select query from the database, we ran it, and how the result set from the database was serialized into the Java world was handled like this. We just had a simple interface with 4 methods for each column we needed, and we let Spring handle whatever it had to do and give us the final result. Now the problem with doing this is this is an interface, it has no implementation which we have written. So at runtime, Spring or Java has to create multiple proxies and factories to serialize all of this data into a usable format. Now the thing is, when we are doing this, what Java does is for every single entry in the database, every single tuple in the result set, it creates an implementation of a proxy factory for each of those rows, with its own additional helpers and factories and methods and data. Now how it worked is, it would serialize all the data and populate it using the factories and stuff. Now the solution I came up with was to use a simple plain object. Here you can see with a constructor, and in this case all that Java or JPA has to do is take all of the result set and call this constructor, as you can see just here. It just runs the query and calls the constructor to result a list of objects. Now you can think about how this could lead us to using less memory, as all JPA has to do is to call constructor and append it to a list. That is all it has to do. But instead, if we were going for the convenience of using the interface projections, we had to do all of these extra things. Now let's see it in action. Here is the 2 endpoints. Now this is the one which is using the plain Java objects. Here you can see when I call it, it doesn't throw any error. And here let's see, here you can clearly see that it takes much more time. Here it was 100 millisecond when we were using the Java object, but when we were using the interface projection, it took 2 seconds. If we try it again, it will reduce a bit, but it's still around 2 seconds, which is a lot. Now let's simulate the error scenario. What I have done is I have passed certain flags and parameters to limit the heap size to 64 megabytes to simulate it. And let's see here, when this is an API I created. So what it does, it calls this same API but iterations of it. So if we try it once, it works, it returns a 30,000 rows, which is a number of dummy data I have in my database table. Now let's increase it to 2, and it fails. We get an internal server error. Now let's see what the other Java object implementation does. Here I have started with 3 and it works. So it uses much less memory. As you can see here, when using the interface, it only worked for 1 iteration. In the second one it failed. Here it can go up to 3 iterations. And I have also configured the parameters to create a heap dump. Now let's look at the heap dump. This is one I had generated previously. I have loaded it, and let's look at the dominator tree. Now this is ranked by how much objects ranking the objects by how much memory it is using and what it is keeping alive. So as you can see here, there is this one specific thread which was spawned to handle our API request, and it took up around 77, almost 77% of the heap space we have. And inside everything which the thread kept alive, there is this array list at the top. Now let's expand it. Here you can see all of the proxies which was created, and here you can see there is around 30,000 proxies created for each of the 30,000 rows. Now let's expand any one of them, and let me expand this. Here you go, and yes, this is it. These are the 4 columns we are fetching from the database. These are the only thing we need from the database, but look at all of these additional wrappers and helpers that Spring and JPA had to create to handle all of this, and this is done for every single proxy 30,000 times, which explains why we needed so many memories. But on the other hand, when we were using the plain Java object method, it used much less memory, and that's all. So this was all about trade-offs. So the convenience of using an interface comes with its own cost of added work the JPA has to do, the added time it would take, and the added resources it would take. So that is all I had to demonstrate. So yes, that is the one thing I have learned. Software engineering is all about choosing the right trade-offs.